Ohm's law states the precise mathematical relationship between voltage, current, and resistance using the following symbols: E, I, and R. E stands for electromotive force, or voltage, which is expressed in volts. I stands for intensity of charge flow, or current, which is expressed in amperes. R stands for the opposition to the flow of current, or resistance, which is expressed in ohms. This equation states that the voltage across a resistor E is equal to the current through the resistor I times the resistance of the resistor R. Let's consider the following example. A battery supplies 500 milliamps to a 10 ohm resistor. What is the voltage of the battery? Well, we know the formula, so let's apply it. We have a current of 500 milliamps going through a 10 ohm resistor. That gives us a voltage of 5 volts. So we can say that a 5 volt battery would be required to supply the 500 milliamps, which is the same as 0.5 amps, to the 10 ohm resistor. The Ohm's law equation can be restated as current equals voltage divided by resistance. Let's consider the following example. A 100 volt source drives a 25 ohm motor through a push button. What is the minimum current capacity of the switch? Well, we know that current equals voltage divided by resistance. So we take the 100 volts and divide it by 25 ohms, and we get a current of 4 amps. Therefore, the push button must be rated for at least 4 amps. The Ohm's law equation can be restated as resistance equals voltage divided by current. Let's take a look at a practical example. A 12 volt source is driving a motor through a 12 amp fuse. What is the minimum value of the motor resistance to prevent blowing the fuse? Well, we know that resistance is equal to voltage divided by current. And we have a 12 volt source with a maximum current of 12 amps. That gives us a resistance of 1 ohm. So the resistance of the motor must stay above 1 ohm to avoid blowing the fuse.